So on to week 5. Here we go. So MATLAB doesn't really pay attention to data types, but it is important to understand how our data is being stored. So far, we've been dealing with numerical values. Those are stored in MATLAB as doubles, which means they're always stored as numbers with lots of digits past the decimal point. We know single values are called scalars, so these are 1 by 1. And then we have arrays with more than one value that are stored in vectors or matrices. So that's pretty good, but we're also going to look at data that stores, or variables that store text. So there's two different ways that MATLAB stores text. The first one is a character array, where it literally stores each character as a separate value in an array. So if I say string equals I am a character, then it's going to store the letter I next to the space, next to the letter A, next to the letter M, next to etc., all the way down. Where this is going to be a 1 by 19 array, so a row array, where each letter or character is a separate value. In order to create a character array, we use single quotes. So here I have my single quotes. It stores it as a vector, and it behaves like a numerical vector, where we can stack character arrays on top of each other as long as they have the same number of characters or letters. And we can concatenate them using the same strategies. Commas put things next to each other, semicolons stack things on top of each other. So if I say long string equals, create a new array, insert this single quote text next to this space next to this text. So I can see, I can concatenate together so that this would store text 1 space text 2 in a single array, where each letter character is a separate value. The other way that MATLAB can store data, and honestly I think this is the better way to do it, is using a string scalar. So where a string scalar is just, it takes a whole word and stores it as one piece. So here we have a double quote string, and this is a string scalar. So the difference between this one and this one is a 1 by 19 vector. This is a 1 by 1 scalar. And string scalars can be easily grouped just like numerical values, where we can stack things on top of each other, put things next to each other, and it doesn't matter if they don't have the same number of characters. I'm putting this scalar on top of this scalar, on top of this scalar, on top of this scalar, on top of this scalar. So I can have a whole array of different string scalars of different lengths. If I want to convert anything to a string scalar, I can use the string function. And honestly, this works for variables as well, or numerical variables as well. If I say string 12, it converts it to a double quote 12, which is different than the number 12. Keep that in mind. If I want to concatenate two string scalars together, then I can add them. So the difference between this string scalar and a character array is, for character arrays, it behaves like our numeric arrays, commas, semicolons. For string scalars, we just say this string, add it to this string, add it to this string. So once again, it'll also say text 1 space text 2. Yeah, so those are the two ways that MATLAB stores text. We have character arrays and we have string arrays. Okay? And it's important to know the difference, and how, because that can help us with debugging, figuring out what our data looks like if we're using single quotes or double quotes. Okay, so now let's go ahead and figure out why we even need to know about characters and string scalars. So the next piece of this chapter, or this week, is looking at two different functions that display data and text to the command window. So the first function is disp. It's a relatively lowly function, very basic, that's used to display data stored in a variable or text to the command window. And it just takes one argument, where I say disp, and then I want to print out this variable, or disp, print out this character array, or print out this string scalar. And when it does that, it is the same as if you left the semicolon off. It just doesn't print out the variable name. So typically, if I say var equals 12 without the semicolon, it'll print out var equals 12. If I say disp var, it'll just print out the 12. It'll leave this part off. That's really what display does. So when the disp function is executed, it prints out the value of the variable without the variable name, or it prints out the string or the message to the command window, and then it immediately follows it by a new line. Essentially, it presses enter. We don't really have a lot of control over how these numbers are printed out to the screen outside of using the format. specifier, format function, format option, which I've talked about before. These are our options. Okay, so these ones should be used in conjunction with disp. Like I said, it's not a very complex function. It's very basic. So we really should only use disp when the exact format of the data is not required. Do keep in mind that disp only has one input argument. So we literally just say disp followed by one value. A lot of times I'll see students do comma, another value, etc. We cannot do that. It's just one forward. It's just one variable, one string, one character array. So if we want to combine data with text, then we need to find a way to convert our text plus data, or convert bringing things into one message before we use the disp function. So there's two ways to do that depending on what kind of data we're working with, what kind of text data we're working with. If we are working with character arrays, then we need to concatenate them together by using semicolons not semicolons, commas to put things next to each other. We don't typically stack character arrays, but we do put them next to each other. So in order to do that, I need to convert my numerical data into a character array. I can do that using the num2string function. So for example, here I'm creating a string that takes the word text with a space placed next to the whatever stored in this variable converted to a string. So if it's 12, it'll convert it to single quote 12 next to, so here's my space, next to space text. So this will put text space 12 text, okay, single quote. And then I can display that string. So that combines my text with my data. Or if we're using string scalars, we can use the addition operator. So for example, it looks like this, where we just say text plus variable plus text, where I don't need to use the string function. It's automatically converted or cast to a string scalar. So once again, if variable stores the number 12, it would say text 12 text, and it's double quotes. And then I can print out that string. Okay? So we need to convert all of our text and data into one variable that we can then display. Note, when you are combining text with numbers, spaces are not automatically included, so make sure you are very tedious and meaningful with how you are combining your text and your data. Okay, the second function is the fprintf function, and this is so much more sophisticated, which means we have so much more control, but it's also used to display data and text to the command window. But now we get to define how we want it printed out. Okay, so here's the fprintf function. It starts with what's called a format specifier, which tells us what we want to print out and how we want to print it out. And then these are optional. We have optional variable, however many variables we need. Okay, it doesn't matter if you're single quote or double quote. Okay, so when, let's say we want to say printf or fprintf, and I want to print out the words hello world, followed by an exclamation point. Okay, it will print out the letters HELLO space WRLD, exclamation point, and then stop. It makes no assumptions in terms of if you want to press enter or anything. It prints out exactly what you mentioned and then full stop. So a lot of times we include escape sequences included in the format specifier to print out white space. So the one you're going to most often use is \n, which says, hey, insert a new line. So now if I say print out hello world, followed by \n, now it will print out the words hello space world, exclamation point, and then press enter. Insert a new line character to press enter. If you want to print out a tab, you can use the \t. It's used kind of, maybe not, not that often. And then these ones are used to print out specific characters, because the \%, and quotation mark are specific characters used to specify things inside of fprintf. For example, the \ is used for the escape sequence. So if you want to print out a single \, you type 2 of them. If you want to print out a single %, you type 2 of them. If you want to print out a single quotation mark, you just type 2 of them. Okay, so that's escape sequences. Another thing we can do is we can combine text with data using something called a format operator. A format operator is typed in this format specifier, which this is the format specifier, and it's used to insert a variable's value into that location in the text. So here I have a format operator, and here I have a format operator, where the first one indicates, hey, insert this data here. The second one indicates insert this data here. So I can see these percent signs, which indicate, hey, insert some data, and then these variables here, these optional variables, they were optional up here, they're not optional down here, to say, hey, insert some data from this variable here. So a format operator begins with a percent sign, and then it is followed by a conversion character. The most common conversion character is %f, or %c, or s, not c, s, where these indicate the type of data to insert. So %f says insert a number, %s says insert text or insert a string. And we can insert as much data as we want to. So you can have as many format operators. However, each format operator must be accompanied by a value stored in a variable. So note there's two format operators here. There's two variables there with data. So when the fprintf function is executed, it's going to go through each line or each character in the format specifier string, and it's going to print it to the screen. If a format operator is reached, the percent sign, then data from the variable is going to be inserted in that location. If an escape character is reached, then the appropriate white space or character is inserted in its place. And then once again, it makes no assumptions about anything else. It will print out exactly what you told it, nothing more, nothing less. Okay? So here's a full table of our format operators and conversion characters. Like I said, %f and %s are the ones we use most often, where %f indicates a number and %s indicates a string or a character vector. I don't like the integer one because I just like this version of %f. You typically don't print out a single character, but sometimes you need to. %e prints out numbers in scientific notation, and %g is the same as short g, where it kind of mixes up how it prints things out. It chooses between one of these, depending on what the number is. But this one I use all the time, and this one I use all the time, sometimes those. Okay, so we can print out data. Turns out the format operator is a little bit more complicated than a percent sign and a conversion character, where we have these optional pieces, conversion specifiers, that allow us to have more control over how a data is printed out to the screen. So there's 3 conversion specifiers: a flag, a width, and a precision. They are all optional. They happen between the percent sign and between the characters, so between the percent and the f, or between the percent and the s. They are most often used with %f, because there's lots of ways to print out a single number. Okay, so they're optional. The flag has the following options. There's 3 options. A minus sign, which left justifies it in the specified width. The plus sign, which prints out the sign in front of a number, so it prints out a positive sign in front of a positive number, and the negative is always printed out. So if I say % plus f, and I'm printing out the number pi, it would say plus 3.14, and then print out, by default, 6 digits past the decimal point. So 3.141592. It might convert that to 3. If I do a 0, it adds zeros if the number is shorter than the width or shorter than the field. Okay, I don't typically use the flag. It's not used that often, but I do have those 3 options. The width. The width is something I do use quite a bit, especially when printing out tables of data. And it's a number identifying the minimum number of spaces used to print out the number. So here I have the number pi printed out to 6 digits past the decimal point, because that's the default. And it takes up 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. The plus is a character, and the minus is a character. So if I say % 15, F. So get rid of that. Nope. I'll keep my flag. Plus 15F. It's going to need 9 characters to print out the number. So it's going to add 6 empty spaces, and then we'll print out plus 3.141592. So this width says take up extra space in front of the number if you have it. So I've got 6 blank spaces in the beginning, and then my 9 characters in order to print out the number. Like I said, I use it a lot to align numbers in a table, like down here says. The last one is the precision, and the precision is used all the time, where the default with %f is to print out 6 digits past the decimal point. So it would print out 3.141592. But if I say %2f, or 0.2f, the precision always follows a period, 0.2f. This will print out 3.14, where it only prints out 2 digits past the decimal point. Or if I say %.4f, it'll print 3.1415. Well, probably a 6. Okay. So precision is used all the time to print out number of digits past the decimal point. Okay, and it always follows a period. Okay. You can use all 3 conversion specifiers. You can use one at a time. You can use 2 of them. So if I say %10.6f or whatever, it's going to print out a number 6 digits past the decimal point. That's my precision because it follows a period, and take up 10 spaces to do it. Okay, there's a lot in fprintf. We will go over examples because it is truly a complicated function, but super powerful. The last 4 functions to go over are related to loading in data from files and saving data to files. So the load function is used to import data into the workspace from mat files or ASCII files. Mat files are specific to MATLAB, and they really are only used to import data from MATLAB or save data from MATLAB. Literally, it's saving the workspace. Exactly how it is. An ASCII file is much more commonly used, where it just stores text data, something you can open in like Notepad or TextEdit or something along those lines. So load. If we want to use a load function, there's 2 ways to use it, more or less, this way and this way. This is specific to mat files, which we don't use very often. But you can say load file name, including the extension. So data.txt or data.dat, those would be ASCII files specifically, file extensions. And what it's going to do is going to load the data from the file and store it in a variable with the same name as the file. So it'll load the data from data.txt into a variable named data. If you are loading in data from a text file or a .dat file, it does need to be square and formatted as a matrix. You can't have empty spaces. If you don't want to save it as a variable with the same name as the file, you can say a equals, where it will load it into a variable named a, or whatever you want that variable to be. If you want to save to a file, you can use the save function. Once again, this is used with .mat files or .dat files or .txt files, text readable. These are ASCII, which just means that they store text readable data. So you can say save file name .mat. This will literally save your workspace and preserve all that your workspace contains. So the name of the variables, the size of the variables, the values in each variable. You can save specific variables by specifying which variables you want to save to a .mat file. Once again, we don't use that one that often. The save to an ASCII format is used more often. So file name .txt, but you need to say you're saving a single variable and indicate that you are saving it as a text readable file. Indicate you're saving it as an ASCII format. Okay, so you need all 3 of these options if you're using save. Okay, and note, only a single variable can be saved with this last option. And numbers are automatically saved inside your documentation. Okay, load and save aren't my favorite functions. I prefer read matrix and write matrix because they're a bit more versatile and they work with text files and spreadsheets as I've highlighted down here. So we can say A equals read matrix and then the name of the file with the extension. So if you say .txt or .csv, which are both text readable, or you say XLSX, it's automatically going to detect what type of file it is, load the data. Once again, it does need to be in a matrix, but it's going to load the data into a variable called A. There's a little bit of flexibility where if there is missing data, I believe it does read it in as NaN, or it does have some indicator to say that data is missing in that location. If we want to save data to a file, we can use write matrix. So it's used to export data. So once again, we can say write matrix, this is the single variable that we are saving. And then this is to what file name. Once again, indicating the extension .txt, .csv, .xlsx, so that it determines what kind of a file to save it in. There are a lot more options for these functions. This is a very basic way to use them. It is a very complex function, but there's lots of documentation. So if you want to read in a specific file type, if you want to read in specific data from the file, you can always look at those additional options. And there we go. That's all the information.